Hi, in this class we will look at the Rankine cycle, which is the basic cycle for the steam power plants. Steam power plants. You know the operation of a steam power plant. There is steam which is generated by the boiler, high pressure, high temperature steam which goes to the turbine, the steam turbine. The energy from steam is extracted in the turbine, and the heat energy from steam is converted into the rotational or mechanical energy of the turbine, and then the turbine is connected with the alternator or the generator. Electricity gets generated, and what happens to steam which has lost its energy? That is taken to a condenser. Condenser is a device which condenses the low pressure, low temperature steam into water, and we call it the feed water, because the feed water gets pumped back to the boiler. Now, these are the essential components in a steam power plant. Boiler generates steam, high pressure, high temperature steam goes into the turbine, where the heat energy from steam does work on the turbine, and then low pressure, low temperature steam is converted in the condenser into feed water, and the feed water is pumped back to the boiler for the next cycle of operation. Now, this is the basic operation of a steam power plant. And the cycle, thermodynamic cycle, based on which a power plant works, is called the Rankine cycle. Now, let us represent the Rankine cycle on a TS plot. The Rankine cycle represented on a temperature entropy plot. Entropy on the abscissa, temperature on the ordinate, the TS plot. That is the vapor dome. You would have read about it in the thermodynamics. Now, how do you get the vapor dome? It is nothing but the locus of points which are saturated liquid points. Saturated liquid points. And this is the locus of saturated vapor points. Saturated vapor points. And this is the region which is the superheated region. And this region to the left of the saturated liquid curve is the subcooled region. And you know this point, which is the critical point. Well, this is the temperature entropy plot. Now, we will represent the steam power cycle, a boiler, a turbine, condenser, pump, back to the boiler as feed water. The basic or the essential components in a steam power plant. Now, if this is represented onto a TS plot, let me start from the expansion of steam from, I presume that it is dry saturated steam. Expansion, and this is what happens in the turbine. The turbine work expansion. Now from the turbine outlet we get the low pressure, low temperature steam as we saw earlier, and that is this point, and this is condensation. Let me just extend the saturated liquid line. So this is the condenser portion. Look at this. What happens in the condenser is the low pressure, low temperature steam gets converted into water, feed water, and that is the condensation process. So we end up at the saturated liquid point. Now during pumping, there is a slight increase in temperature. This is pump, and I have a boiler accessory. I'll come to this later, which I'm going to call the economizer. I'll explain this later. And this is saturated liquid point. And the boiler converts the saturated liquid into saturated vapor. So this is the boiler portion. So the boiler, change of phase is there from saturated liquid to saturated vapor, and the condenser again change of phase from a mixture. Now under the vapor dome you have a mixture. So please understand, under the vapor dome we have the mixture of steam and feed water, and beyond the saturated vapor line we have the superheated region, and beyond the saturated liquid line we have the subcooled region. So this is the basic Rankine cycle. We call it basic Rankine cycle because it involves the representation of the basic components in a thermal power plant. So what are the basic components in the thermal power plant? You have basic or essential components in a thermal power plant. We have the boiler, whose job is to convert saturated liquid into saturated vapor. Number two, we have turbine, which extracts work from steam. So here is where the thermal energy contained in steam is converted into rotational energy or mechanical energy. And third, the condenser. Condenser converts the low pressure, low temperature steam, the wet steam, into the feed water, otherwise called condensate, and then we have the pump, which pumps back the feed water back to the boiler. So these are the main components in a thermal power plant. Is it okay that we run a power plant in this fashion. Look at the turbine work. The job of a mechanical engineer is to ensure maximum work is extracted in the turbine. Now, look at this. Saturated vapor is expanded in the turbine and we end up in a wet state. And the entire expansion in the turbine happens in the wet region. Did you hear me say that? The entire expansion of steam happens in the wet region. The biggest disadvantage of this is expansion is happening in the turbine and then the wet steam is going to condense on the turbine blades. Now, wet steam condensing on the turbine blade will lead to erosion, and so we end up with disadvantage. There is a disadvantage that wet steam is condensing on the turbine blades. So that is one disadvantage. The other disadvantage is your work extraction is only this much. And you would want the boiler pressure to be a little higher. And you would want condensation to take place even at lower pressures. Even at lower pressures. Mind you, this is a constant pressure line. Constant pressure. Isobar, otherwise it is called an isobar. So, there are certain modifications you would need if you want the power plant to run at greater efficiencies. So, there are certain modifications that are possible on the basic Rankine cycle. So, we will look at it. Let us now look at the modified Rankine cycle. So, I told you why do we need to modify a Rankine cycle. It is in order to get greater efficiencies out of the steam power plant. We saw that basic Rankine cycle is this. This is the boiler, the turbine, the condenser, the pump, and an economizer. Before I explain the modified Rankine cycle, I want to tell you what an economizer is. We saw that the basic components are essential components in a steam power plant are 1 boiler, 2 the turbine, 3 the condenser, 4 the pump. These are essential components in a steam power plant. Now, when I want to enhance the efficiency of a steam power plant, I go for a modified Rankine cycle. Now, a modified Rankine cycle is one where I'm going to use certain accessories. Okay. Boiler accessories, I call them. The first one can be the economizer. Economizer is a boiler accessory. The job of a boiler is to convert the saturated liquid to saturated vapor. That is all a boiler does. Conversion of saturated liquid into saturated vapor. A phase change happens in the boiler. But then you see, when the steam comes out of the turbine, it is in low pressure, low temperature condition, and it gets into the condenser, and after the condenser it becomes the feed water. Now this is what is pumped to the boiler, and look at this. I am bringing the feed water into the boiler in the saturated liquid form at a higher temperature. Now this is your temperature at the condenser, Tc, and this is the boiler temperature, Tb, the boiler temperature. And by way of pumping, there is a negligible increase in temperature. Then you can see here I have marked the economizer. Now economizer is a boiler accessory. It is nothing but a tube which is placed in the path of the flue gases. Flue gases are the products of combustion. You have ash, one product of combustion, when you are burning coal, and then you have got flue gases. The flue gases are simply escaping to the atmosphere, carrying with them a lot of heat. Now, I place in the path of the flue gases the economizer tube. Now through the economizer, I send the feed water, whose temperature is the temperature at which it gets condensed, or perhaps slightly an increased temperature. This is a very, very negligible increase. I have shown it much out of proportion here, but then it is a very, very small temperature increase. So feed water comes into the economizer, which is placed in the path of the flue gases, and the waste heat from the flue gases is given to the water, feed water, which flows through the economizer tubes. And what happens here is feed water comes out at a higher temperature. Now what essentially has happened here is the sensible heat of the feed water is increased. Please catch that point. Sensible heat increase in the feed water, and I bring the feed water to this point where I am delivering it into the boiler, where just conversion to saturated vapor point takes place. So this is an accessory. And economizer heats up the feed water using the heat from the flue gases, which otherwise would have gone waste into the atmosphere. Now, the vapor dome, the condenser, the pump, economizer, the boiler portion. You see what we did here, this is a simple Rankine cycle. This is a simple Rankine cycle. What we have done, we are expanding steam from the saturated vapor point downward. It would be good if you can take it to a still higher temperature, then expand it. What have I done here? The saturated vapor point steam, or steam which is in the saturated vapor condition, has been heated, and I call it the superheating. I have superheated steam to a higher temperature. I have superheated steam to a higher temperature. Now, let me please draw the vapor dome slightly. Okay. So, I have increased the temperature of steam beyond the saturated vapor point, and then it comes here. Remember, this is an isobar. This is an isobar. At the same pressure, I am increasing the temperature of steam. Now, look at this expansion. It is only a smaller expansion, meaning less work output only is possible from steam. Whereas here, you can see there is a greater expansion possible. This is your CP, critical point. I am able to get greater work output from steam because of superheating. So, the superheating is done in a device called superheater. That is another accessory I would call superheater. The steam superheater. So, because of superheating, you are able to get greater output from steam. Now, to put things simply, efficiency is output by input. The simple definition. When I am able to get greater output from steam, the efficiency of the Rankine cycle increase. So, that is a modification which I can do in the Rankine cycle. Okay. Now, you can see here the biggest advantage. Only this much of portion is expansion in the wet region. So, only the last few stages of the turbine blades are going to be affected by this wet region expansion. There is going to be condensation on the turbine blades, whereas you see here this much of expansion has happened in the dry region or the superheated region. So, this is one of the biggest advantages of superheating of steam. So, superheating is one method by which we are able to enhance the efficiency of a steam power plant, and this is one of the ways we modify a steam Rankine cycle. Now, we have increased the temperature of steam. Look at another methodology of increasing the efficiency. Now, I'll be able to get a greater expansion, let us say till this point, if I'm able to bring the condenser portion here. If my condenser can come here instead of here, I bring it down, I'll be able to get still greater expansion. This much of greater expansion is possible. When that is possible, when I am reducing the condenser pressure. When I am reducing the condenser pressure. Expansion is greater, work output is greater when the condenser pressure is further decreased. So, this is the second method of improving or modifying the efficiency of the Rankine cycle. So, we have first superheating steam, two, decreasing condenser pressure. I will be able to modify the Rankine cycle this way and get greater work output and hence greater efficiency. The third methodology of increasing the efficiency is increase boiler pressure. Now, look at this. If I am able to increase the boiler pressure, bring it here, I am able to get a greater work output again. I am able to get a greater work output. So, increasing boiler pressure is another method of modifying the Rankine cycle. Increase the boiler pressure. This is a new pressure. The fourth method of modifying Rankine cycle is reheating steam. Reheating steam. Now, let me draw the reheat cycle here for you. This is superheating, SH, and expansion is done in the high pressure turbine. This is expansion in high pressure turbine. Expansion in high pressure turbine. And I reheat steam and then I expand it in the turbine. The advantage, you are able to see almost very little amount of expansion happens in the wet region. So, this is the reheating of steam and then further expansion in the turbine. So, this is a reheat cycle. Now, how is reheating done? You have steam coming out of the high pressure turbine. Let us say this is the steam inlet to the high pressure turbine, and after expansion the high pressure turbine, I take it to a reheater. This is a reheater, and the reheater is placed in the path of the flue gases again, the flue gases. So, flue gases We saw that it was already used in the economizer for preheating the feed water, and now you have the reheater placed in the path of the flue gases, which takes steam from the high pressure turbine, and the reheated steam is again admitted to the low pressure turbine, and these two are coupled together, and then this is coupled with the generator. Now, reheater is nothing but a simple coil through which steam from the high pressure turbine is made to flow, and the reheater is placed in the path of the flue gases, and the reheated steam now enters the low pressure turbine and further expansion, and then it goes to the condenser. And you can see here additional work output is possible. This and then this. So additional work output is possible when I am reheating steam. So I can call the steam reheater as one of the accessories. Steam reheating is a modification of the basic Rankine cycle. Fourth one. And the fifth one can be feed water heating or feed water regeneration. Feed water regeneration. We will look at it now. Let us now look at the fifth method of modifying the Rankine cycle. It is called the feed water regeneration. We regenerate feed water using a portion of the steam which is expanding. Now look at it, it works this way. This is superheating and expansion of steam. This is the condenser portion, pumping, and what I do, a portion of the steam which is expanding is taken, or it is bled, we call it as. A portion of the steam is bled, bleeding of steam from the turbine, and it is mixed with the feed water here. So the feed water is heated using the heat of steam, and then it is pumped again. And again, next, I have some more steam which is taken, and then it is mixed here with the feed water, and then it goes to the boiler. So this is feed water regeneration, and this is also feed water regeneration. What we do, we take a portion of the steam from the turbine, and we have the feed water which is coming out of the condenser. We take it to a feed water heater. This is steam which is bled from the low pressure turbine, so I call it as LP feed water heater, low pressure feed water heater. A portion of the steam is mixed with the feed water in order to increase its sensible heat. Temperature is raised, and pump it again, and then bring it again to the next feed water heater, which is called high pressure feed water heater, wherein we bleed some steam from the high pressure turbine. Mixing happens and then it is it is pumped back to the boiler. It goes to the boiler and from the boiler it goes to the turbine. So, feed water temperature is raised by mixing a portion of the steam which is bled from the low pressure turbine stage as well as the high pressure turbine stage. And this means I am enhancing or I am increasing the sensible heat of the feed water, and I am able to spend little fuel only in the boiler. So, my coal which is burnt, the heat that is required to be given in the boiler for the feed water is reduced, and I am able to get greater efficiency. So, this is called regenerative feed water heating. So, what is the idea? When you are raising the sensible heat of the feed water, the quantity of coal that is required to be burnt for raising the sensible heat of the feed water is reduced. And this is one way by which I can modify the Rankine cycle. So, now you got 5 different ways of modifying a Rankine cycle. A modified Rankine cycle will result in a better efficiency of the steam power plant. Thank you.